There we go, it's working. Okay, were there any questions on the previous page, number 14? We're gonna move on to 15. What? Yes? I'm glad to go over if you're still confused on anything, like if there's any clarification you need on any of these, but really the purpose of 14 is just to get you to understand how to answer a question like this, to like understand the answer. So, and for now, I'm asking you to draw the picture. Going forward, there's going to be like, it'll kind of depend on your mental picture of things, how much you need to like jot down to understand what the answer to this is. But anyway, so the first question you'd ask is, where is that? Where is 2 pi over 3?
Top left
Top left.
quadrant.
Yeah, so it's 2/3. So there is a collection of things you have to pretty much have memorized, which I'll quickly jot down over here. You got to know the proportions of a 30, 60, 90. Okay, so you got to know that. You got to know the proportions of a 45, 45, 90. Got to know that. And you gotta understand that on the unit circle where you end up, the x value tells you about the cosine, and the y value tells you about the sine. What am I missing? Is there anything else you kind of have to just like know? Yeah, you got to know that a full circle is 2 pi radians. Okay. And you have to know, I guess the other thing is you got to know your SOHCAHTOA. And you got to know that with that comes so sine goes with cosecant, cosine goes with secant, and tangent goes with the reciprocal. So I think if you have that picture sort of like ingrained in the brain, you should be fine. So I guess the point I'm trying to make is you don't have to have like, you guys have seen the whole unit circle all at once, right? Mm-hmm. You don't have to have that whole thing memorized. That's a crazy amount of information. All that whole thing is just contained. It's just this being repeated over and over. Right, Zane? Oh, okay. So 2 pi over 3, that's 2/3 of the way from here to here. So 1/3, 2/3. So if you're being asked for the sine, do you want to know the y value or the x value at that point? You want to know what the y value is. So firstly, is the y value positive or negative? It's a positive number. And 2, which triangle is it if you're dealing in thirds of pi? It's this one. And this angle right here is a 60. Right? This little angle in here is a 60. So therefore, how big is this? How tall is this?
3 1/2.
Not 1/2. Root 3 over 2. So the answer to this is root 3 over 2. Cool beans? All right, let's do 1 or 2 more. Just for funsies, what's the cosine of this angle?
Opposite. Half.
It would be negative 1/2. Negative 1/2. Okay? Make sense?
Yep.
Okay.
Let's do F.
We're going to do A, B, C.
D, E, F.
We'll talk about F, yeah. And I'll give you spoiler alert. A negative angle is just you go clockwise instead of counterclockwise. You start at the same place and you just go boop, boop, boop. Same thing. But wow indeed. Wow indeed. Cosine of 5 pi. So this process I'm describing will eventually, I hope, take place in the brain, just mentally. So, where is 5 pi, first of all?
It's at the one right there.
Keep here.
No, up. Nope, down. Nope, left. Up, left. Down a tiny bit. Nope, up a tiny bit. Up
Tiny bit more.
a little bit more. Nope, down.
Just not just J/K. So this is 0, right? So it's starting here, you go pi, 2 pi, 3 pi, 4 pi, 5 pi. So 5 pi, by the way, if you think about it, wouldn't any odd multiple of pi just end up in the same spot? 1 pi or 3 pi or 5 pi or 7 pi or 9 pi, right? Where all the even multiples would end up here. So anyway, so then I'd say, well, for cosine, I want to know what's the x value of where I landed. And so the answer would be negative.
Easy.
That's it. No triangle needed. We like these ones. So the easiest ones are typically when you land here, 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 because you don't even have to involve the triangle. Don't have to worry about like orienting the triangle on the circle.
It's trying so hard to find a triangle to draw.
Okay, the tangent might be, I don't know, it might confuse you slightly, but maybe not. Let's do the tangent. Tangent of pi over 6 is, okay, first location. Well, that's a pretty simple location to find, right?
Yeah.
Now for the tangent, I got to know the opposite over adjacent ratio. So is that going to be, can you directly get that from the x to the y? Not directly, right? But do you guys see what we're going to do? On this triangle, you're going to take the opposite divided by the adjacent. Right? The opposite is the y, and the adjacent is the x. So maybe I could have added that to my collection of information, that the tangent is given to us by the y value divided by the x value. Does that make sense? Okay. So it's the sine value divided by the cosine value. Okay. So anyway, what's the y value then? 1/2. What's the cosine value? √3/2. So this next step, honestly, most people just end up memorizing like what the tangent of pi over 6 is, but you don't have to. Let's do it. It's 1/2 divided by √3/2. Cool beans? Now how do you simplify that? Now, you might go, there's a lot of ways you can kind of think about what that means, but here's one way. We know that dividing by a fraction is the same as multiplying by the reciprocal. And these twos hit us with a canceling Bobansely. And then what are we left with? 1/√3. And then do you guys remember what we, nothing wrong with that number. It's a totally fine number, but
Why
it's,
don't you just go 3 to the 1 to the.
what?
Just turn it to √3/3.
What's wrong with that answer?
Nothing wrong with this, but there's just a, rationalize the denominator. Like for example, is there anything wrong with writing the number 3/6?
No.
No, it's just that you could write that as 1/2 and it's a little bit nicer. 1/√3 is a totally fine number. It's just that a lot of times it gets written as this. Those are equivalent numbers. Okay. In the context of trig and stuff, this is definitely the more common one you'll see. Is the tangent of pi over 6 is √3 divided by 3. Cool beans?
Yeah.
What was that?
That's a van.
That's a van?
Yeah.
Oh, that's someone driving by.
Yep.
It's
Wow.
recording.
It's the part of the excitement out in the parking lot.
It's
Yeah, they're just making noise, and that's all they're doing.
That was a high-pitched horn, though. It sounded like a,
Air horn.
yeah. Oh,
thought
so it wasn't a
trumpet.
car horn. A
Well,
car
it
horn to me
was.
sounds
It
deeper
was.
than that.
You can make
Maybe
your
it was
car
an
horn.
air horn.
I've always thought that your car should have two buttons. One is like a friendly, like beep beep, like hey, you've just given you like oh you're
I'm
not
right
paying
here.
attention. It's a green
And the
light.
other one is just a human voice screaming.
The other one is just the ear crushing. I hate you.
This is all my snap credits right now.
All right. By the way, while we're on tangent, let's just skip down to E.
Yeah.
E. Was that a meme or was it B? Which one's the meme?
It
Was
was
it E
E.
or B?
E.
Both of them.
E.
It was both.
Yeah.
That's true.
If you E with like the Markiplier, mixed with E.
Markiplier.
What's Markiplier? Okay.
He's a YouTuber.
Guy. But B.
Oh, where it was the guy from Shrek, but they made him look more human.
Yeah.
It was the combination of Markiplier, which is
That was E.
That was back in the golden age of memes where I'd be like, hey guys, what's a good memes? And they'd show me like just a picture of this weird looking uncanny valley Shrek character with the letter E. And I'm like, dang, that's art.
This is meme.
That's a meme. Now, something bad has happened. The memes, I'm like,
Now you
my
just get
grandma would
expressions.
understand this. That's not a meme. Anyway, sorry. Sorry for the meme rant. Forgive me. What's the tangent of this? First question would be, where is he?
Right there.
Right there. No.
Right here,
Yeah.
right? So you go 1/3, 2/3, 3/3, 4/3, 5/3. Or maybe you thought of it as I'm 1/3 away from a full 2 pi, right?
Mm-hmm.
So, no?
Yeah, there's.
Does that make sense?
Yeah.
So I'm 1/3 of a way. So that means this angle here is 1/3 of pi, or 60 degrees. So my x value is 1/2, and my y value is, I better be careful, it's negative. It's negative √3/2. So my tangent, this is why the triangle is pretty critical, because now you look at this and go, well, who's the opposite, who's the adjacent? Well, the y value is the opposite, and the x value is the adjacent. So you go negative √3/2 divided by 1/2. What's going to happen when you divide those numbers?
Oh my God.
Negative 3/3. No, just kidding.
Multiply by the reciprocal, right?
Cancel, Mansell.
Cobancely.
√3.
Ooh, that's a nice number.
Mhm.
That's a nice number.
That's a nice number.
Right, JB?
Yeah, you have to get one.
Wait, which one? Yeah.
J Baldwin.
J Ballin. That's your new name, J Ballin.
Oh, there you go.
Okay. How are the feelies? Do you guys feel like you understand it well enough?
Yes.
I
Okay.
don't know how to do 9
You
and
got it,
or
side
I
now.
and J.
I and J.
Yeah,
You can do.
one of them.
Sure.
How do you know which triangle you have? I'm still kind of confused on that.
So I actually have physical triangles somewhere in here. If I can't find them now, I'll find them later.
We have to go.
I just reminded me. Oh, what? They were stolen. No, they were stolen. Dang it.
Do you need to make Donald J Baldwin?
That's devastation. Well, you have to. I had these triangles where you could actually take them and like flip them over and see how to put them on. So, what you gotta. So, okay, so you know the two triangles, right?
Mhm.
This guy's kind of skinny. Let's look at this one, for example. Since this is pi over 6, and this is pi over 3, you understand how if I want to be 5 pi over 3, then like this angle here, like this slice, that's a pi over 3. So I go, well, how do I fit that triangle in this space? Well, I gotta fit it in so that this angle, the pi over 3, is right there. Does that make sense? So then, like, where's one where we use this triangle? Like, yeah. So this one is a pi over 4. So if you're doing a pi over, if your thing in here, if your angle is over 3 or over 6, that tells you you're using this triangle and fitting that in there. If it's over 4, using this one.
And if it's over 2, it's also that one?
No, if it's over 2, let's do the one that Eddie was talking about, I. So I is sine.
Yeah. Yeah.
3 pi over 2. So when you're talking about halves of pi, how many degrees is half a pi?
90.
90. So you're talking about chunks of 90, quarter circles. So when you do this, you go, well, so negative angle just means go the opposite way. We typically go counterclockwise or anti-clockwise. We're going to go clockwise, starting at the same place. So starting here, you go 1/2.
Maybe we shouldn't go outside. It's pretty
You
loud.
go 1/2.
Get it.
We'll go outside another time. First of all, when we go outside, I have to email the office, hey, we're gonna be outside in case anyone calls. So we'll do it another day. I know how nice it is outside. It simplifies my life.
We can go back.
No, because
I want to be on the news, Hall.
this is 0. Okay, just listen. This would be, I got to go 3/2 of pi in the opposite direction. So that's 1/2, 2/2, 3/2. You all understand how to get there?
Yes.
So by the way, so negative 3 pi over 2 radians is pretty much the, I'm not saying it's the same number, but it's pretty much the same location on the unit circle as a positive pi over 2. You feel that?
Yes.
Okay. What's the sign here? The nice thing is, once you have the location, you don't have to care at all about what the number was. Because all you care about now is what's the y value of this point. So what's the answer? 1. So anyway, so Nikita, so to recap, if your angle has a 3 on bottom, it's going to be this triangle but flipped, like it's, you're going to be dealing with this angle. If it's a 6, you're dealing with this angle, but it's still the same triangle. If it's a 4, you deal with this triangle. If it's a 2 or if it's not a fraction, you're just going to end up like here, 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 here. In which case, there's no triangle at all.
That makes sense.
We all understand?
Yeah.
Okay. You said J as well, right?
No, we're
Oh.
good. I just didn't understand the one negative one.
What's the answer to J then?
HMU.
HMU.
Oh wait, which line is it?
1.
1.
No.
Oh. Never mind.
Let's do J. J's a weird one. J's tricky.
The sign of the cosine would be 1.
I'm gonna keep. Here's a hint for you. You can probably figure it out before I say the answer if you remember that the y divided by the x tells you the tangent value. Where's 9 pi over 2? Up here. You can count it off, but I don't know. So 9 pi over 2. Counting it off's okay, but you can be like, oh, isn't that just 4 pi plus an extra half a pi?
Yeah.
And 4 pi just gets you back to where you started, right?
Mhm.
2 pi, 4 pi, plus an extra pi. So great, okay. So, oh, by the way, 9 pi over 2, I guess is equivalent to negative 3 pi over 2. That's weird. But the tangent of 9 pi over 2 is, did anyone figure it out?
Undefined.
Undefined. Because you do the y value of 1 divided by the x value, which is 0, and be like, wait a second, that is undefined. Moral of the story. Hey guys, is the tangent function defined for all inputs?
No.
No. It is undefined for numbers. There's actually another location on the unit circle where you'd have an undefined tangent. Right here. So if your x value, so because of this definition, if the x value is 0, your tangent is not defined. How about the tangent here?
That's
Fine.
Then you have 0 over 1, which is fine. 0 divided by 1 is just 0. So your tangent, the tangent graph is really weird, by the way. If you're wondering, you're like, well, what happens in the tangent graph?
There's a tangent there?
Yeah, you can graph anything.
But
It was
why
like-
would you?
For the means. It actually goes like this. It goes. Does that forever. It goes.
Whoa.
It's actually a sick TikTok dance. You know?
Can you show me?
Wait, does that mean the code?
Yeah, because you got like x squared,
Yeah.
and absolute value of x, and then tangent be like.
Okay, what are the other graphs look like?
What?
You got cubic, cube root.
No, I mean like tangent, sine, cosine.
Sine is just sine just goes
Sine waves.
sine wave. Cosine wave is the same thing, but it's shifted.
Wait, does that mean tangent's the same? Cotangent's
No.
the same?
The cosecant and secant graphs are pretty lit.
Oh.
Those are pretty